So let's say you have your BAM files, let's say mapped. You have your BAM files, let's say ls map. All right, I'm going to do it here. Mapped star.bam. Let's say you have 2 BAM files or 3 or 10 or maybe 50 or 100. If you want to run feature count on all of them, then this is how you do it. You will say feature counts like this, and then you will specify your options. All right, so the options, we use -T8. We said -S0 for strandedness. We have unstranded data. We said -P --count read pairs. That is for what? Paired and reads. We have -T exon. That means the feature of interest is exon. The identifier, we said -gen. We are using gen ID. And then minimum mapping quality, we said 10. Annotation file, that's the GTF, we said -A data/ref /dm6.gtf. That's the GTF file. Then when it comes to the output, all right, you specify a name. So I'll say count/gens.counts. All right, I already have my directory created, so I'll specify a name. So I'm saying gens.count because now I have multiple files, so I should have a name that makes sense. Okay, that's descriptive. All right, so that's what I have here. Then the inputs, I'll say mapped/star.bam. So once you have it this way, then you can run it. So let's execute this command. Perfect. So once you execute it, feature counts will look at the files, and then it will analyze and give you the outputs. Let's look at the output. So if you ls into count now, we are going to find what? gens.count. So now you see them here. Okay, so when we ls into count, you will see gens.count. Okay, gens.count summary. Okay, so this has the information. I can say count. I'll say gens.count.summary, and it will give me what? The information. All right, so I have assigned, unassigned, unmapped, etc. So it will give that information for the BAM files. Okay, so you have 2 BAM files or 2 samples. Let's use BAM files, okay, to make it simple, because we are analyzing BAM files. So for each BAM file, it gives you the status. Okay, so we have that here. So we have this 1177, this is 1180. The same thing for the gens.count file. So let's say head counts gens.counts. The same information. So we see that here. All right. So here. All right. So there's it. Now it's time to actually explore this count file. I made mention earlier that we are going to open it with a spreadsheet software. So what you should note is that this is a tab separated file, despite the extension that I use. Let me just do it again here. All right, despite the extension that I use, that's .count, this is a tab separated file. That means that the columns are separated using a tab character. So you can open it with a spreadsheet software. That's what we are going to do now. I'll show you. So let's go to counts. Yeah, so I'll just open it. I have my spreadsheet software here, so I'll open it for you to see. So this is it. So for the feature counts output file, the count file itself, so there's what you have. It tells you the command that was used, which is here. It tells you the column. So we have gen ID, which is here. I will just undo it for each of the gen. We have chromosome, start and strand, length, and then after this we have the different BAM files. So we have this and we have this. All right, so there's it. So when you are going to perform your differential expression analysis, it is this file, the information here, that you will use to do the differential expression analysis. Now let me also say that what the output here, all right, if you look at the names here, you see we have map/gsm 4611177, etc. Okay, for this BAM file, the same for this BAM file, right? So before you do your differential expression analysis, you will need to do some formatting to make sure the naming is okay, everything is fine, and then you extract just the counts, okay, for the differential expression analysis. Now, depend on your objectives, you may need to also do some analysis using the information here. All right, but then for the differential expression analysis itself, it is the count that you use. Also, for that one, you need to do some further processing. Now, if you have such a data and then you need some help, you can always contact me, book a session, and we can look at how to properly format this data and then run it in tools like the SIG2. Okay, so for differential expression analysis, you can use tools like the SIG2. You can use tools like HR, Lima, etc. All right, so I've covered some tutorials on how to also use the SIG2. All right, now if you have this, then you can also do the multi-QC, and this time what you need to do is to specify just this one here. All right, because you have everything in this file. All right, so that's how we do it. This also, you can also open it with a spreadsheet software. That's also fine. So you just have to know how to do with that. Okay, so I repeat, once you have your file, your output file, you need to do some processing before you can now push it to the differential expression analysis tools to do the downstream analysis for you. Okay, so if you are interested to learn how to perform differential expression analysis using the SIG2, then watch this video right here.